Welcome to lesson 2 of What is Slope? In this video, we'll have a look at some more problems. So example 1. Jeff is installing a handrail and needs it to be the same slope as the stairs pictured below. What slope should Jeff use for the handrail? Now picture this invisible line connecting the edge of each stair. That's what we're going to be finding the slope of. Now finding the slope of the entire staircase, or just one stair, will be the same because slope is constant throughout a line. So I see that all the stairs have a rise of 6 inches and they have a run of 12 inches. Now I'm going to reduce that to 1 over 2. Now notice I didn't write this as 1 inch over 2 inches, and that's because slope does not have units. Now a slope of 1 over 2 could mean it has a rise of 1 centimeter and a run of 2 centimeters. It could mean it has a rise of 1 foot and a run of 2 feet, or like in this case, a rise of 1 inch to a run of 2 inches. It doesn't matter the units, as long as the ratio of 1 to 2 is preserved. So now I'll write that the slope of the handrail should be 1 over 2. Example 2. Francis needs to build a roof that has a pitch of 1 over 12. Or a slope of 1 over 12. If the dimensions she used are below, did she build it correctly? And if not, how can she fix it? So for this roof here, I see that it has a rise of 2 feet and a run, not of 24 feet, of 12 feet. We got a half 24 here. Now, usually we reduce fractions. We would reduce this to 1 over 6, but pitch is always expressed as a fraction over 12. So I'm going to leave this as simply 2 over 12. So now to answer the question if she built it correctly, I'm going to say no, she did not build it correctly. Because her slope, or her pitch, is 2 over 12 and not 1 over 12 like it should have been. So now in order to correct this, there are several things that she could do. One simple suggestion would be to simply change the height of the roof. Instead of having it 2 feet, she can have it 1 foot. And keep this at 24. So that means her slope would have a rise of 1 foot and the run would be 12 feet, like she should have. So now I'll say to correct this, she could change the height to 1 foot. In example 3, it says a road sign warns drivers of a steep hill ahead. The sign indicated a 20% grade, which means it has a 20% slope. We have to change this to a fraction and then state what this means for drivers. So here a slope is given as a percent and we have to change that to a fraction. So to remind you what to do, I'm going to make a note. To change a percent into a fraction, write the number over 100 because percent means per 100. So 20% is the same as 20 over 100. Now I can reduce this by dividing top and bottom of the fraction by 20. And that gives me 1 over 5. So now, since we know that slope is rise over run, we can now state what this means for drivers. This would mean that for every, say, 5 units horizontally, the road drops 1 unit, where the units could be replaced with meters, kilometers, feet, whatever the case. So let's say that this means that for every 5 units horizontally, the road drops 1 unit. And now for the last example. A wheelchair ramp should not have a slope more than 1 to 6. Does the following ramp meet the recommended guidelines? So let's first write down the recommended slope here. The recommended slope, written as a fraction, is 1 over 6. Now let's find the slope of the ramp. So it has a rise of 3 inches and a run of 12 inches. Now, in order to compare two fractions, then we need to find a common denominator. So I see that a common denominator here between 6 and 12 is just 12. So I can simply multiply this fraction by 2 to give me 2 over 12. So now I'm able to see that the ramp is actually more than the recommended guideline of 2 over 12. So to answer the question now, I'm going to say no, because the ramp has a larger slope than what was recommended. Now, finding a common denominator here between the two slopes was fairly straightforward. If you did have more difficult fractions, then you might want to change them to decimals in order to compare them. So to do that, I would do 1 divided by 6 on my calculator, and that would give me 0.16 repeating. I would change 3 over 12 into a decimal as well on my calculator, and I get 0.25. So again, I see that the ramp is bigger than what's recommended. So either way, finding common denominators or changing them to decimals, we see that the ramp does not meet the recommended guidelines.